Okay, so now we're going to do some side work. So we're going to rotate our model to the side. The side that we're going to be working on in the face of the operator. Okay, we're going to do a 2D. We're going to do a 2D contour. We're going to use the same 1/2" end mill, but this time we need to go to machining type. We're going to pick tool orientation. And we need to select what direction the z-axis will be facing. So if I pick on this face, it flips the z-axis in the orientation we want. X-axis should already be in play where it should be, but just to be thorough, pick a line that's in the x-axis of our part and make sure the orientation is the correct direction. Alright, now we're going to go to geometry and we're going to select using the single selection tool. We're going to select a single segment and we're going to select the top edge of our chamfer that we have modeled there. Okay. Alright, I'm going to put a tangential extension of 1/8 of an inch. That should get us to the edge of our raw material. Just make sure it's a straight line and not leading in using a lead-in move. We're going to hit OK there. On your geometry tab, make sure the arrow is on the correct side of the part. It predicted wrong for me in the first time. We're going to go to the heights tab and we're going to leave everything at default. Here we want our retract planes higher so we have some time for it to react. We're going to go to the passes tab. We're going to use wear compensation. We're going to come down here. We're going to do roughing passes. We're going to do those in 0.2 increments. Okay, and we're going to do 8 stepovers. We're going to come back up and finish stepovers. We want to do a finish stepover 0.01. Okay, the next tab on multiple depths, we are going to do multiple depths. Our maximum step down is going to be 0.0125 as well. Sorry, 0.125. We're going to do one finishing step down and we're going to do that at 10,000ths. Step, we want nice clean spring passes. We can finish at final depth. We can rough on final. We're going to use even step downs. We are going to do stock to leave, and here's what we're going to do. We're going to put 0 axial, but on radial we're going to put negative 0.125. So we're going to go an 1/8 inch beyond that edge, just to clear that out for other cutters that come in. We don't need smoothing on. Feed optimization is not going to do anything on a straight line. We're going to go to linking tab. We're going to keep the tool down. We're going to do a 0 degrees, so we're going to come in straight in on the end. That means our linear lead distance needs to be more than half the diameter of the cutter, so it's 0.26. Our vertical lead in radius is going to be 0. And then we're going to hit OK. Okay, so that should mill off starting from the outside inward, but leaving the surface that was cut from the end alone so that we can see if there's a witness line between those two steps. So that's the facing. Now what we can do is we already did a pocket on the top that we can copy. Okay, we're going to take our pocket that we used in the top of our part on the side with 4 holes in it, and we're going to right click on that and we're going to say duplicate. Now that we've duplicated that pocket, we're going to move it down in sequence to be last. Okay, we're going to right click on it, we're going to go edit, and we're going to change some parameters so we can use it on this side here. We're going to go to multi-axis, which is probably the most critical one. We're going to check the tool orientation. We're going to select a z-axis plane that's perpendicular that flips our z-axis. We'll go ahead and pick something in x-axis and flip it just so that it's been registered. Then we're going to go to geometry and we're going to clear out the selection we had and we're going to pick our new pocket on the inside. Make sure you pick the edges and not the surface itself. I'm going to go to the heights tab. We're going to revert these to stock top just to give us some more clearance, and then we're going to go to the linking tab, and we should be able to keep all that at default. And I'm sorry, the heights, the passes tab, leave it all at default. Linking tab, leave everything at default, and hit OK. All right, and so we've misapplied the same toolpath to this side face. Okay, that's the last routine that you needs the 1/2 inch end mills. We're going to finish off programming the routines on this side. Okay, the next common feature that we have that also occurs on all the rest of the faces we want to go ahead and program. So we're going to go to 2D. We want to clone these two operations on the other faces of the part. So here's how we go about doing that. We're going to go to Setup, and we're going to create a new pattern, and we're going to make that a circular pattern. We're going to select our axis. We're going to pick something round, so let's use the rotary axis. That gives us our spin center, and we're going to do 4 instances. Okay, so once we do 4 instances, it should populate, and we're going to leave it by order by tool. And we want to move our pocket in there as well. So you should have the 2D contour followed by the pocket inside this folder, and then the circular pattern will do indexing moves to move this into each orientation for just like on a 4th axis. Now I'm going to change the name of that folder to 4x pattern 1. Okay, so now we're going to go through and we're going to do all the other features. We're trying to keep from changing tools a lot. We're going to come back and do deburring at the very end. And so we have now, we've done the rotary moves for everything with the 1/2 inch end mill, which is going to be this pattern here. Okay, so the next thing we're going to do is we're going to do each of these unique features that wrap around the side that use the 1/8 inch end mill to make these pockets. So you're going to do 2D pocket. We're going to select the 1/8 inch end mill from our library. And we're going to leave the default feeds and speeds. On multi-axis, we need to pick tool orientation. We're going to pick the face that's facing up. We're going to pick something in the x-axis. What do you know? It didn't flip on us this time. And then we're going to go to geometry, and we're going to pick the bottom of our pocket. We're going to go to the passes, the heights tab. I'm going to say we're just going to leave all this at default except for the top height. We're going to go to selection. We're going to pick the bottom of the pocket. That way we're only machining this little pill-shaped area. Okay, and we're going to go to the selected contours. We're going to go to passes. We'll do multiple depths on this. We're going to do half the diameter cutter in depth, so 0.06. We're going to do 1 finishing step down. We're going to leave that 10 thousandths for that to be removed. We'll use even step downs. We will do finishing passes. We're going to use wear compensation. We're going to do 1 finishing pass, and we're going to leave, smoothing deviation is going to be 4/10. Our step over is going to be 0.06, 0.01. So 10 thousandths. We're not going to leave any stock to leave. We do want to turn on smoothing because it's a round feature. And we can turn on feed optimization, although I kind of suspect it won't do anything. And we're going to pick more spiral. Maximum step over is going to be 0.065 or 0.06. Okay, we're going to go to our linking tab. We're not going to do a vertical lead in. We're going to keep the tool down. And I don't think there's going to be enough room for a helix here, so let's do a straight plunge with this end mill. And it shouldn't put a lot of torque on that part. And we're going to hit OK. Alright, so it's not real big feature. We're pretty much doing one rough, one finish in height and in width because it's such a small feature. So now we're going to rotate our model to the end, and we're going to repeat this feature in a couple other places. Now we have one down in this pocket, and we have these other ones up at the top. So we're going to duplicate our routine. We're going to edit that. We're going to keep the default feeds and speeds. The next tab, we need to reselect what's z-axis. Orientation, make sure z is pointing up. Our x-axis should be in the horizontal. And looks like in this case it didn't force me to change anything. We're going to go to geometry. We're going to clear our selection. We're going to pick the one in the center. Arrow should be on the inside. Okay, so we're just going to select the one on the bottom of the pocket because our start point's different. We'll go to the heights tab, and we need to clear out the selection from the previous one. We're going to select the top of the pocket. And we're going to go to passes, linking, all that stays the same. You pretty much get the same cut we had in the last one. Now we're going to make another duplicate of this routine, and we're going to right click on it, go edit. And we don't need to set the orientation because we've already done that. We're going to go to geometry, and we're going to clear out the first pocket we did, and we're going to select these other ones. And the reason we're doing that is they start at a different height. We're going to go to passes, and instead of face, we're going to deselect that, and we're going to go from model top. And then the rest of the two tabs should be the same. We hit OK. And now we've machined our other little divots there. Alright, let's go on to the next tab, our next face, the side with 6 dimples on it. We're going to duplicate the routine we just did. Right click on the pocket. We have to leave first tabs the same. We go to multi-axis. We're going to pick a different face for Z orientation. We need to pick a different edge for X. If it flips, you'll have to check the box. In my case, it did not. We're going to go to geometry. We're going to clear out all the geometry that was selected before. And then we're going to reselect the bottoms of each of these 6 little pockets here. And then we go to heights. This can stay at default as long as it says model top. Hit OK. Alright, now we have our features that go 6 times there. Now we're going to face number 2. And we're going to duplicate this same routine. Right click on the duplicated routine. We're going to go to multi-axis. We're going to pick a different face for Z orientation and a different edge for X. If it flips, you might have to check this box. Go to geometry. We're going to clear out the geometry that's already in there. We're going to select our 2 pockets. Go to the heights tab, leave that all at default. Linking tab, leave that at default. And last one, default. We hit OK. Alright, so we've now machined all of the divot type features. Now let's return to the top. So we're done with the 1/8 inch end mill. Now we have the option to deburring or drill these out. So I'm going to elect to do the drilling first. Again, this is in 3-axis mode, so because the table's in a neutral position. So we're going to go to drilling. We're going to pick from our library, our spot drill. And we're going to select just the, we're going to go to geometry, we're just going to select the chamfer only. Do not check the entire hole or it'll go too deep. And that's for our spot drilling. We're going to go to the heights tab. We're going to leave it at stock top. We're going to go whole top for the whole bottom. Make sure the cone is just going as short as that, otherwise you've made a selection error. On cycle, we're going to go to deep drilling. On this, I do want to go a little more conservative than we have on the other machine. So we're going to go 60 on our peck depths, just a little bit less. We're going to go to linking, leave that alone, hit OK. So now we have our our edge breaks on these longer holes. Now these are reamed holes, so we're going to go in with a 246 drill, which should be standard in our library. So we're going to go to drilling. We're going to select from our library letter D drill. Keep everything at default. We're going to go to geometry. We're going to select the chamfer, the top of the hole, the smaller hole, and the in the very bottom. So the bottom, the next hole, chamfer. Okay, so we want it to go all the way down to where the drill tip is, not just where it's reaming. Go to the heights tab. We should be able to leave all this at default except for we're going to check the boxes tip through bottom. We're going to go to cycle. We're going to do a deep drilling cycle, full retract. Leave that at default, and then we'll hit OK. The tool 9 should be able to drill down into there. Now there should be an assignment where you built a reamer. The tutorial on how to build that reamer is attached to this assignment as well, but please reference that video to build a reamer tool. So you're going to go to drilling, and we're going to select the reamer that you've built. The 251 number 19 drill. Okay, we're going to leave everything at default settings on feeds and speeds. We don't have to do anything on the multi-axis tab because it's facing the spindle in the neutral position. We're going to go to geometry, and this time we're just going to select the chamfer and the upper portion of the hole. So the upper portion of the hole and the countersink. Because we want it to stop where the shoulder is at the bottom of the selection. And we're going to go to heights tab. We can leave all that at default. Cycle reaming, default, hit OK. So if you've done it right, our drill is going to go deeper than our reaming.